Hey guys. Okay, let's go over chapter 4, lesson 3, multiplying fractions. The essential question for this chapter is to ask yourself, what does it mean to multiply and what does it mean to actually divide fractions? There's a difference. We have two goals for this lesson. The first one's kind of obvious, it's in the title. We're going to multiply fractions. The second goal, we're going to simplify before multiplying those fractions. Okay, you'll see that once you learn how to do this, it makes the math much easier. All right, before we go over goal number 1, I want to remind you how you actually multiply fractions. And all it is, you multiply the numerators and you multiply the denominators. Keep this in mind, part to whole, part to whole. The numerator is what you have, and denominator is what you're supposed to have, the whole. Okay, so 2 out of 5, we have 2 parts out of 5. You multiply the numerators, 2 times 1 is 2. Denominators, 5 times 2 is 10. You get 2/10. But don't forget to simplify when it's possible. 2 and 10 are both even numbers. That means you can simplify them by a factor of 2, which means you have 1 out of 5, or 1/5. Just remember, the denominator, the bottom number, can never be 0. Now, if you forget that, think of it this way. Does it make sense? Would you ever make a set of 0? Why would you want a part of 0? Okay, so if the denominator is 0 and you have 1 out of 0, does that really make sense? Anyways, we're going to go over the got it's and see what you think, okay? This is letter A. Again, you should do math in pencil. Don't forget about that. Don't, because unless you're perfect, you're going to make mistakes, and that includes me. So, hey, do these problems to find out. Okay, we have 1/2 times 3/5. Okay. Let's do the equation. You have 2 ways of doing this. The first way, method number 1, is equation. This one is what I just did. It's pretty straightforward. Make sure you copy the problem correctly, because that's where most people make mistakes. So, okay. Numerators are 1 and 3. 1 times 3 is 3. Denominators 2 and 5. 2 times 5 is 10. That's it. That's all it is. 3/10. But I want to show you why this works. Method number 2, you're familiar with this. It's where you draw a model, use a model. Okay. So I'm going to write the equation again. 1/2 times 3/5. So far, so good. The first fraction is 1/2, so I'm going to draw 1/2. There's my 1/2. Right? 1/2. I'm going to circle a little bit just so that's separate. Okay, 1/2. And 3/5. Bear with me. You're like, what are you doing? You'll see. 3/5, you look at the denominator, means you're making sets of 5. And out of those 5, we have 3. So let's shade that in. All right. Let's talk about what this really means. Okay. You start off with half. Okay. You have half. 1 out of 2. And you're going to multiply it by something that's less than 1. 3/5 is less than 1. By definition, a fraction is less than 1. We're talking about proper fractions. So you only want this. But you only want something that's even less than this. You want something that's less than half. Okay? So 1/2 times 3/5. 1/2 times 3/5. Now I'm going to write it again, but a little differently so you can see what's going on. Same thing. Start out with 1/2. And then I'm going to draw my 3/5. You can put this on the top or the bottom, doesn't matter. The idea will be the same. 3/5. Again, look at the denominator. Look at the denominator of the second fraction. I'm making sets of 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's my set of 5, but I only want 3 out of those 5. So 1. Yeah. So I'm going to draw it a little darker, okay? The overlap where they both mix, where you see the pencil and the marker cling together. I'm going to fill it out a little bit more so you can see, is right there. Okay. I'm going to define the lines just a little, make them a little dark so you can see what I'm doing. Okay. All right. Look what happened. Remember I said focus on the denominator? We started off with a set of 2. Yes? 1 and 2. Right? We only have half of that. We only have one piece out of 2. There's my 1. The denominator here says, hey, for this piece, you're going to cut that up into 5 pieces. Which is what we did here. And out of those 5 pieces, you only want 3 of them. Okay? So, the denominator is going to change. What does it take to have a full set now? It's not 5. It's not 2. It's actually 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? By taking that 5 and multiplying it by the 2, you made 10. Right? Look at this. You only have the 1 out of 2, but you still got to look at the whole set. So by drawing these lines and changing it into a set of 5, if you do the other thing you don't have, now you have 10. Right? That's why the denominator is 10. But you only want 3 parts out of that 5. 1, 2, 3. There's a 3, but why don't I count this? Remember, you didn't have this to begin with. You only have this. You're only cutting the 3. You only want 3 pieces out of the 5 that you made out of the piece you had. So how many pieces do you actually have? 1, 2, 3. Let me do if I can do a pen here, maybe. 1, 2, 3. 3/10. Okay. This is why the equation works. This is what you're actually doing. Okay. All right, I'm going to do letter B. We may not have space for the model, but we definitely have space for the equation. All right, 1/3 times 3/4. Make sure you copy the problem correctly. Okay, numerator times numerator is 1 times 3 is 3. 3 times 4 is 12. That's denominator times denominator. And always simplify when it's possible. 3 and 12 have a common factor of 3. Oops. See? And I'm the math teacher. I make mistakes, people. Gotta keep an eye on me. Alright. Remember, how does that work? If you're not sure if you can divide by 3. Well, one, you have to know your times tables. If you do know your times tables, this is not that hard to figure out. But let's say you don't. 3 is a multiple of 3. 12 is it a multiple of 3? Yes. How do we know that? If you add the digits, 1 plus 2 is 3. We talked about this a while ago, remember? Divisibility rules. And 3 is a multiple of 3 again. So how many groups of 3 can you make from 12? 4. It's just times tables. 4 times 3, 1 times 3. Anyway, the answer is 1/4. All right. I'm going to do an area model real fast. The first fraction I see is 1/3, so I'm going to draw 1/3. Maybe draw a little bigger so you can see what's going on. Sets of 3. I have my sets of 3. 1, 2, 3. I only have 1 out of that 3. There's my 1/3. All right. Our fraction is 3/4. Okay. The denominator says I'm now making sets of 4 if I go up this way. Okay. Maybe I'll put little arrows this way so you can see what's going on. Yeah. 1/3 left to right like this. 1 out of 3. Going up this way, 3/4. Well, I'm making sets of 4. 1, 2, 3. Oh, that's enough. Look at that. So awesome. All right, I have my set of 4. 1, 2, 3, 4, right? Each piece now becomes 4. 1, 2, 3, 4. Because that's what this means. Each piece now becomes 4. But here's the deal. I want 3 of the 4. So, going this way, there's 3 out of 4. Okay? If you don't believe me, look at it this way. 3 columns out of 4, right? Okay. But now you have to look, where do they mix? Where do they cross? I see a mixture of pencil mark and marker here. 1, 2, 3. I have 3 parts, right? 3 parts. But what's the total now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3/12. Here's it again. You have to simplify, okay? If we have a set of 12, right, and we have 3 out of that 12, it comes down to 1/4. Now, I can already see where some of you are going to be complaining, wait, where did you get that 12 from? Where did you get that 12 from? Where did it come from? Just remember, when I drew the 1/4, I only had one little bar shaded in. 1 out of 3. 1 out of 3. And when I multiply it by the 4, the 3/4, I'm saying, hey, now that for each piece you have, I want you to cut that piece into 4. 1, 2, 3, 4. But here's the deal. You also have to do it to what you don't have. You have 1/3, but you don't have 2/3, but you still have to cut those into 4 pieces as well. Okay? That's where the 12 comes from. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you get 3 out of 12. Okay? Which is, if you simplify, it's 1 out of 4. Okay? Now, you may not be seeing it. Look. Let's look at this. 3 12s, right? We're making sets of 3. How many sets do we have here? This is going to be a little weird, so bear with me here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Right? I have 4 sets of 3. But I only have one that I have to worry about. This one, where the marker and the pencil mark meet. And that's 1 out of 4 sets. Okay? Anyways, moving on to C. Two-thirds times 5, 6. Oh, I should have done a pencil. Numerator times numerator is 10. Denominator times denominator is 18. 10 and 18 are both even numbers. I can use 2. I can make 5 groups of 2 out of 10. I can make 9 groups of 2 out of 18. 9 times 2, 5 times 10, right? 5/9. Okay, some of you are like, I don't want to do that. I don't want to see the drawing. Let me just show it to you anyways. On the day of the test, if you choose not to do drawings, that's fine. If you want to do equation, that's fine. But when we get to word problems, it might help to draw pictures and see what you're actually doing. Okay? We have 2/3. Ooh, that's not good. That's not a good fraction. Think to yourself, why am I erasing this? Why is this not a good fraction? The part's supposed to be equal. I made one piece way bigger than the other. Now, I'm not going to be perfect unless I take out a ruler and measure everything, but I'm not going to still off. But you know what? That's good enough for now. Look at the denominator first. I'm making sets of 3. 1, 2, 3. But I don't have the full set. I only have 2/3. I have 2 out of the 3. Okay? I have 2 out of 3. And then I'm going to multiply it by 5/6. So 5/6 is in 1. What it's saying is I have 2 pieces out of the 3. And what little I do have, I only want part of this. I don't want the whole thing. I only want something less than this. I want 5/6 of it. Okay, now look at the denominator. Now we're making sets of 6. That means each piece now here becomes 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Right? Each piece now becomes 6. That means you have to do it for all of them. You know what? Might as well continue. I only want 5 out of 6. So then you highlight, if you have a highlighter, 3, 4, 5. So it's almost the whole thing, but not quite. Now, here's the deal. How many parts do we now have? By taking each piece and make it into 6, what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, I'm putting this on the side. Part to whole, part to whole. That should be a mantra. Part to whole, part to whole. We have 18. But how many pieces do we actually have? Again, to begin with, we only have these 2 pieces. And when I cut up those 2 pieces into 6 pieces each, now I have 12. Right? 6 and 6. But I don't want all 12. I only want 5/6 of that. Right? 1, 2, 3, 4, 5. You know, let's just count together. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 10 parts out of 18. Yes? And if you simplify, just keep in mind, what are you doing when you simplify? If you forgot, you're making sets of 2. How many actually sets of 2 do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 sets of 2, right? Which makes sense. There it is. 9 sets of 2. And out of those 9 sets of 2, I have 5, right? 1, 2, 3, 4, 5. I'm just looking at this, not these. Excuse me. Remember, this was blank to begin with. There was nothing there. Okay, and that's it for goal number 1. All right, here we go with goal number 2. Goal number 2 was simplifying before multiplying. I just want to remind you something before we get started. I want to remind you what a factor is. Factors are 2 numbers you multiply to get a product, as I showed here. 2 times 3 is 6. Factors are 2 and 3. Get you 6. Again, I showed it also visually. 2, groups of 2, 1, 2. 3 times 1, 2, 3 gives you 6. Or if you want to say 2 groups of 3, 3, group of 3, twice is 6. So 2 and 3 are factors. The order doesn't matter. You get the same product. As you said, that's the proof. All right, so let's go over letter D. All right, we have 3/5 times 4/9. And doing what we did before, 3 times 4 is 12, 4 times 9 is 36. You divide by 12. They both have a common factor of 12, right? How do I know that? And realize that I can multiply 12 times 3 to get 36. There's a connection. That means I can make 12 a factor. And the answer is 1/3. This is what you normally do. So what is goal 2? How is goal 2 different? Sorry, I can't speak there. Before you multiply anything out, it's asking you to simplify. Okay? I'm going to rewrite it a little differently. Let's see what's going on. You look at the numerator and the denominator. If any of the numbers have a common factor, you can simplify by that common factor to make the numbers even smaller. So I'm looking at this. I'm looking at this. I realize 4 and 4 have a common factor of, guess what? 4. Right? 4 divided by 4. 4 divided by 4. And I'm also noticing, hey, the 3 and the 9 have a common factor of 3. Right? It kind of looks like a butterfly thing, but honestly, you don't have to call it that if you don't want to. So let's do the division. 3 divided by 3 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. I'm looking at this. 4 divided by 4 is 1. 9 divided by 3 is 3. Numerator times numerator is 1. Denominator times denominator is 3. Same answer. The trick is to look at the numerator and denominator and see if you have a common factor. Now I realize the way I did it here, you might be like, whoa, wait, that doesn't make sense to me. I'm going to do it again. A little differently. Bear with me. Okay. It's going to start out the same, but watch what happens. Okay. Remember when we said with multiplication you change the order of multiplication to make the math easier? All right, what happens if I do this? Instead of 3 times 4, I put 4 times 3. Because really that's what you're doing. Think of it. You have a set in parentheses. 3 times 4, you got to multiply the 2 together. And whatever you get here, you're going to divide by this. 4 times 9. Right? You're playing with the numbers. I want you to see what's actually happening. I'm going to break it apart. 4 and 4, you can divide by 4. 3 and 9, you can divide by 3. 1 over 1 times 1 over 3. You're manipulating the numbers. You're playing with the numbers. Okay? The goal here is to simplify before you make the numbers bigger. Right now, these are easy. You can probably just multiply straight through and then simplify after. But when you get to bigger numerators and bigger denominators, it really does help to simplify first before you multiply big numbers. Okay? But it's your choice. I'm just giving you a tool that you might choose to use later or not. That's up to you. I just want to show you that when I did this whole divided by 4 here, what am I doing? In my head, I kind of moved the numbers around. I changed the order. Now, hold on. Before I can change the numbers going left to right. 3 and 4, 4 times 3. That gives me 12. Don't go switch numbers top and bottom. You have two different equations. Okay? I want you to see what here. I want you to see this. If I were to show you what it really looks like as a division problem, you're not going to switch the 9 with the 4 inside here, or this 4 with that 3. Okay? You have two different equations. Okay? I can switch the order here, yes, and then simplify here. Okay? Anyways, I just want to show you that. And let's go to the letter E. 5/6 times 9, 10. I'm going to rewrite it. Okay, I'm looking at the numerator, I'm looking at the denominator. The 5 and the 6 don't have a common factor. The 5 and the 10 do. They have a common factor of 5. Now, if you want to do this, just so you can remember, that's fine. You don't have to. Okay? The 6 and the 9, they both have a common factor of 3. Okay, 5 divided by 5 is 1. 6 divided by 3 is 2. 9 divided by 3 is 3. 10 divided by 5 is 2. 1 times 3 is 3. And yes, I know I should be using pencil. Kind of got excited in the moment. And there it is. Okay. If you don't feel comfortable doing this, it doesn't look right to you, by all means, you can put the numbers that have some in common. You can change the order if you will. And then just simplify those fractions individually. Hold on, you're like, wait, that's an improper fraction. You can have an improper fraction while you multiply, while you divide. It's in the final answer that you can have an improper fraction, okay? In the end, the improper fraction must be changed to a mixed number, okay? Okay, I switched the order of the numbers around. I split it up into two fractions. I simplified those fractions. There it is. You'll get the same answer. Again, more than one way to do this. All right, letter F. If you notice I stopped drawing area models, I hope you understand how this works. 3/5 times 10. Oh, all right, reminder of lesson 2. 3/5 times 10. I'm going to change the whole number to a fraction. Okay. In my head, I'm kind of doing this already. 3 and 1 don't have a common factor. 5 and 10 have a common factor of 5. 3 stays the same. 5 divided by 5 is 1. 10 divided by 5 is 2. And the 1 stays the same. 3 times 2 is 6. 1 times 1 is 1. This is a division problem. 6 groups of 1, excuse me, is 6. Okay. Again, the simplifying before you're multiplying. Why do it? It prevents you from having to simplify bigger numbers later. Okay? But in the end, you decide what works best for you. Okay? And that's it. Thank you.